Today we are going to learn about real-time object detection with YOLOv5. You will gain the skills to set up and deploy YOLOv5 for real-time detection tasks, a critical component in fields like autonomous vehicles and surveillance.
Welcome to our session on real-time object detection with YOLOv5. In this introduction, we'll explore the YOLOv5 model, a cutting-edge tool in computer vision that stands for You Only Look Once. This model is renowned for its speed and accuracy in detecting objects in real time, making it a preferred choice for AI applications in autonomous vehicles, security surveillance, and more. YOLOv5 is the latest iteration, offering significant improvements in performance and usability over its predecessors. With YOLOv5, developers can achieve faster inference times and higher accuracy, which are crucial for real-time systems. In this video, we aim to equip you with the skills to implement YOLOv5 in your projects, enhancing your ability to develop sophisticated AI solutions.
To begin working with YOLOv5, the first step is setting up your development environment. Start by ensuring Python is installed on your system. YOLOv5 is compatible with Python 3.7 and above. Next, create a virtual environment to manage dependencies separately from your system's Python installation. This is crucial for maintaining a clean workspace and avoiding package conflicts. Once your environment is ready, clone the YOLOv5 repository from GitHub. This repository contains all the necessary scripts and configurations to get started. After cloning, navigate to the directory and install the required dependencies using pip. The requirements.txt file in the repository lists all necessary packages. It's essential to verify your setup by running a test script provided in the repository. This step checks if all components are correctly installed and your environment is ready for development.
With your environment set up, the next phase involves preparing your dataset. YOLOv5 requires datasets to be formatted in a specific manner, typically using the Coco or Pascal Voc formats. These formats include images and corresponding labels that define the object's classes and bounding box coordinates. To label your images, you can use tools like LabelInc or RoboFlow. These tools allow you to draw bounding boxes around objects and assign class labels. Once labeled, organize your dataset into directories for training, validation, and testing. This structure helps in efficiently training and evaluating the model. It's crucial to ensure your dataset is diverse and balanced across different classes. A well-prepared dataset significantly influences the model's performance, so spend adequate time in this phase to ensure high-quality data.
Once your dataset is ready, you can proceed to train the YOLOv5 model. Begin by configuring the training parameters in the YAML configuration file within the YOLOv5 directory. This file specifies the path to your dataset, the number of classes, and other hyperparameters. For effective training, consider using pre-trained weights. YOLOv5 provides weights trained on the Coco dataset, which can serve as a good starting point for transfer learning. Adjust the batch size and number of epochs based on your dataset size and computational resources. Larger batch sizes can speed up training but require more memory. Throughout the training process, monitor the progress using the built-in visualization tools. Check for signs of overfitting or underfitting by evaluating the model's performance on the validation set. Adjust hyperparameters as needed to improve the model's generalization. Following the initial training, the next step is optimizing your model's performance. Fine-tuning involves adjusting hyperparameters such as learning rate, momentum, and weight decay to enhance accuracy. Implementing data augmentation techniques can also improve model robustness by exposing it to varied data conditions. Techniques like random cropping, rotation, and color jitter can be applied during training. Evaluating model accuracy is crucial for understanding its performance. Use metrics like precision, recall, and map, mean average precision, to assess its effectiveness. Additionally, consider employing learning rate schedules to adjust the learning rate dynamically during training, improving convergence. Finally, benchmark the model's inference speed to ensure it meets your real-time application requirements. This involves testing the model's prediction speed on different hardware configurations to determine its suitability for deployment. With a trained and optimized model, the next challenge is deploying it in real-time applications. First, set up an inference environment similar to your development setup but optimized for speed. YOLOv5 can be integrated with video streams by using frameworks like OpenCV to capture and process frames for object detection. For applications on resource-constrained devices, such as drones or mobile robots, optimize the model using techniques like TensorRT, which accelerates inference by optimizing the computation graph for NVIDIA GPUs. Consider the deployment platform, whether it's cloud-based, on-premises, or edge devices, and ensure compatibility. This might involve converting the model to different formats or using specific optimization libraries for the target platform. Handling multi-platform deployment efficiently will ensure your application can run seamlessly across various devices and environments.
Integrating YOLOv5 with popular machine learning frameworks enhances its interoperability and extends its capabilities. If you're working with TensorFlow, you can convert YOLOv5 models to TensorFlow format using the ONNX, Open Neural Network Exchange, framework. This conversion allows you to leverage TensorFlow's ecosystem for additional processing or deployment options. For PyTorch users, YOLOv5 is natively compatible, allowing seamless integration into existing PyTorch projects. ONNX serves as a bridge for cross-platform compatibility, enabling you to deploy YOLOv5 models across different runtime environments. Additionally, consider using REST APIs to serve the model in a web application, allowing clients to send requests for object detection. Building a simple web interface using frameworks like Flask or Django can make your object detection system accessible to a broader audience, demonstrating the real-time capabilities of YOLOv5 effectively.
Deploying YOLOv5 can present several challenges, and being prepared to troubleshoot common issues is vital. One frequent concern is model accuracy, which might degrade when transitioning from development to production. Ensure that the deployment environment closely mirrors your training setup to minimize discrepancies. Hardware compatibility issues, such as differences in GPU or CPU capabilities, can impact performance. It's essential to test the model on the target hardware and make necessary optimizations. Memory constraints can also pose a problem, especially on edge devices. Techniques like model quantization can reduce memory usage. Model loading errors might arise due to mismatched dependencies or incompatible library versions. Thoroughly document your environment setup to mitigate these issues. Finally, ensure consistent performance across platforms by conducting rigorous testing and benchmarking under various conditions.
In conclusion, we've explored the robust capabilities of YOLOv5 for real-time object detection and how it can be effectively deployed in various applications. From setting up your development environment, preparing and training your model, to optimizing it and deploying it, you are now equipped with the fundamental skills needed to implement YOLOv5 in real-world scenarios. The future applications of object detection are vast and promising, spanning industries from autonomous driving to intelligent surveillance systems. As you continue to explore the potential of YOLOv5, remember to engage with a thriving community of developers and researchers who contribute to its ongoing development. We encourage you to apply your newfound knowledge in innovative projects and stay tuned for the next advancements in object detection technology. Thank you for joining us on this journey.